December 3, 1944. The skies above Tokyo. Corporal Matsumi Nakano of the Imperial Japanese Army Air Force banked his Kawasaki Ki-61 Hien fighter into a steep climbing turn, his eyes locked on the massive silver shape above him. The Boeing B-29 Superfortress, tail number 4, 2-24735, commanded by Lieutenant Charles Fetter, droned steadily through the thin air at 27,000 feet, its 4 Wright Cyclone engines leaving contrails in the frigid atmosphere. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Nakano had already expended his ammunition in previous passes. His 20mm cannon shells had struck the bomber, but the American aircraft continued flying, its crew still alive, its mission not yet aborted. The Japanese pilot faced a choice that thousands of his countrymen would face in the coming months. Return to base having failed to stop the enemy, or sacrifice everything in one final attack. He chose sacrifice. Pushing his throttle forward, Nakano aimed his fighter directly at the B-29's tail section. The collision shattered both aircraft. Metal screamed against metal. The bomber's tail broke away, sending the massive aircraft into an uncontrollable dive. Nakano's Hien, its nose crushed and wings crumpled, somehow remained controllable enough for the pilot to execute a desperate belly landing in a rice field outside Tokyo. He survived. Lieutenant Fetter and his crew did not. But what happened next revealed something far more disturbing to Japanese military planners than the loss of one bomber. Within days, engineers from the Koku Gijutsu Kenkyujo, the Air Technical Research Institute, arrived at the crash site. They had been waiting for this opportunity since November, when American B-29s based in the newly captured Mariana Islands began their systematic campaign against Japanese home islands. The wreckage of Fetter's bomber lay scattered across farmland southeast of Tokyo, its aluminum skin twisted and torn, its systems exposed to examination. Japanese technicians swarmed over the debris, photographing every component, measuring every dimension, documenting everything they could learn before the wreckage was transported to Tokyo for public display. What they discovered in those first hours of examination challenged every assumption Japanese military planners held about American industrial capability. The bomber represented a level of technological sophistication and manufacturing precision that Japan had never achieved in any aircraft program. Every component, every system, every design decision revealed an industrial philosophy fundamentally different from Japanese practice. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Boeing B-29 Superfortress had entered combat operations against Japan in June 1944, operating initially from bases in China. Those early missions proved logistically challenging and operationally limited, with bombers struggling to reach Japanese targets while carrying meaningful bomb loads. But in November 1944, everything changed. The capture of Saipan, Tinian, and Guam in the Mariana Islands provided the United States with airfields within striking distance of Tokyo itself. From these island bases, 1,500 miles from Japan, American B-29s could reach any target in the Japanese home islands while carrying their maximum internal bomb load of 20,000 pounds. That figure alone represented a quantum leap beyond any bomber in Japanese service. The Mitsubishi G4M, Japan's primary twin-engine medium bomber, carried a maximum bomb load of 2,200 pounds. The Nakajima G8N, a 4-engine heavy bomber that entered limited production near the war's end, might theoretically carry 9,000 pounds, but never approached operational deployment in meaningful numbers. 20,000 pounds, 4 times the capacity of the American B-24 Liberator, 5 times that of the Boeing B-17 Flying Fortress, 10 times the payload of Japan's frontline medium bombers. The number seemed impossible to Japanese engineers who understood the weight penalties associated with long-range flight. Every pound of bomb load meant 1 less pound of fuel, reducing range. Every pound of defensive armament reduced payload capacity. Every design decision involved trade-offs between competing requirements. Yet the Americans had somehow built a bomber that could carry 10 tons of explosives over 1,500 miles while flying at altitudes approaching 30,000 feet, altitudes where Japanese fighters struggled to maintain performance, altitudes where the thin air reduced engine power and maneuverability. The wreckage from Nakano's ramming attack provided the first close examination of B-29 components Japanese engineers had obtained. Previous encounters with the Superfortress had been limited to observation from attacking fighters or analysis of scattered debris from bombers shot down over water, where recovery proved difficult or impossible. Now, they possessed substantial sections of airframe, engines, defensive armament, control systems, and most critically, the sophisticated fire control equipment that coordinated the bomber's defensive guns. The fuselage sections revealed construction techniques that astonished Japanese engineers. The bomber's skin consisted of aluminum alloy sheets formed with precise consistency across every panel. Rivet holes aligned with mathematical precision. Structural members showed identical dimensions regardless of which section of the aircraft they came from. This was not craftsmanship. This was mass production executed with precision that Japanese factories had never achieved. Japanese aircraft construction still relied heavily on skilled workers who fitted components individually to each airframe. Panels were hand-formed over wooden molds. Rivets were installed by experienced technicians who understood how much force to apply, how to compensate for variations in material thickness, how to achieve proper joint strength through experience and feel. The American approach appeared entirely different. The B-29's construction suggested that machines, not craftsmen, had formed the panels. That automated equipment, not individual workers, had drilled the thousands of rivet holes. That precision tooling, not skilled fitting, had ensured that components from different subcontractors assembled together without adjustment. Engineers measured rivet spacing across multiple panels. The variation measured less than 0.02 of an inch. Such consistency was impossible to achieve through hand installation. The bomber had clearly been assembled using automated or semi-automated riveting equipment that ensured uniform installation depth, uniform hole spacing, uniform joint strength across thousands of rivets. The engines proved even more revealing. The Wright R3350 Cyclone 18-cylinder radial engines that powered the B-29 represented the most powerful production aircraft engines in the world at that time. Each engine produced 2,200 horsepower at takeoff, giving the bomber's 4 engines a combined output of 8,800 horsepower. Japanese engineers carefully disassembled one engine that had survived Nakano's ramming attack relatively intact. What they found confirmed their worst fears about American industrial capacity. Every component showed precision machining to tolerances measured in thousandths of an inch. Crankshafts, connecting rods, cylinder barrels, pistons, all displayed identical dimensions. The consistency suggested that any component from one engine would fit directly into another engine without modification or adjustment. Japanese aircraft engines required skilled assembly by experienced technicians. Components were often hand-fitted to achieve proper clearances. Mechanics in the field needed extensive training to perform major repairs or overhauls. The American system appeared to have eliminated such requirements by building precision into the manufacturing process itself. The implications extended far beyond the immediate question of engine repair. If American factories could produce engines with such precision, they could produce them rapidly. If parts were truly interchangeable, field maintenance became dramatically simpler. If workers needed less skill because precision came from the tooling rather than the craftsman, production could scale up quickly by training new workers rather than waiting years to develop skilled mechanics. The defensive armament system demonstrated technological sophistication that Japan had never attempted to implement in any operational aircraft. The B-29 carried 12 50 caliber Browning machine guns, positioned in 5 remotely controlled turrets, plus a manned tail position containing 2 additional 50 caliber guns and initially one 20mm cannon. What made this armament revolutionary was not the number of guns, though 12 heavy machine guns certainly exceeded the defensive firepower of any Japanese bomber. What astounded Japanese engineers was the fire control system that coordinated these weapons. The General Electric Central Fire Control System allowed any gunner to take control of multiple turrets from his sighting station. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. A gunner in the upper forward compartment could aim and fire not just the upper forward turret above his position, but also the upper aft turret and either of the two lower turrets. The computer gun sight automatically calculated lead angles based on target range, speed, and deflection. The system compensated for aircraft motion, altitude, temperature, and ballistic drop. Japanese bombers relied on manually aimed flexible guns or simple powered turrets where gunners aimed by eye and fired based on experience and instinct. The accuracy of defensive fire depended entirely on the skill of individual gunners. The American system used electronics and mechanical computers to enhance human aiming, allowing even relatively inexperienced gunners to achieve hit probabilities that Japanese pilots found devastating. The sighting stations themselves revealed American approaches to crew efficiency. Each gunner sat in a pressurized compartment with clear visibility through optical sights, insulated from engine noise, protected from the -50-degree temperatures at altitude, supplied with heated flight suits and oxygen systems that functioned reliably at 30,000 feet. Japanese bomber crews endured conditions that would have seemed primitive by comparison. Gunners stood in open positions exposed to hurricane-force winds and temperatures far below freezing. Oxygen systems proved unreliable at extreme altitudes. Communication between crew members was difficult due to engine noise and inadequate intercom systems. The pressurization system that allowed American crews to operate in relative comfort at altitudes approaching 30,000 feet represented technology that Japan had attempted but never successfully implemented in any production. Aircraft. The B-29 featured 3 separate pressurized compartments, the forward compartment housing the pilots, bombardier, navigator, and flight engineer, the rear compartment containing the gunners and radio operator, and a separate pressurized tail gunner position. A pressurized crawl tunnel connected the forward and rear compartments, allowing crew members to move through the aircraft despite the unpressurized bomb bays amidships. Japanese engineers examining the wreckage could see the complexity of the system. Pressure bulkheads sealed each compartment, valves regulated airflow, relief systems prevented overpressurization. Heating systems maintained comfortable temperatures despite external conditions that would freeze exposed skin in seconds. Japan had never fielded a pressurized aircraft in operational service. Several experimental programs had explored the technology, but none had progressed beyond prototype stages. The manufacturing precision required to build pressure-tight fuselage structures exceeded Japanese industrial capabilities. The weight penalties associated with pressure bulkheads and regulation systems reduced payload capacity to unacceptable levels when Japanese designers attempted to incorporate such features. Yet the Americans had somehow integrated full pressurization into a bomber that still carried 20,000 pounds of bombs over 1,500 miles while maintaining combat altitudes above 25,000 feet. The trade-offs that forced Japanese designers to abandon pressurization programs apparently didn't constrain American engineers, suggesting access to more powerful engines, lighter structural materials, or more efficient systems integration. The bomb bay design revealed another American advantage. The B-29 featured 2 separate bomb bays positioned fore and aft of the wing center section. This arrangement kept the fuselage narrow, reducing drag and improving aerodynamic efficiency. Bombs were released alternately from each bay by intervalometer to maintain proper aircraft balance during the drop sequence. Japanese bombers typically used single bomb bays or external racks that created substantial drag penalties. The G-4M medium bomber, for example, carried bombs externally on racks beneath the fuselage, significantly reducing maximum speed and range. The B-29's internal bomb carriage eliminated such drag penalties while providing the structural strength to carry loads far exceeding anything Japanese bombers could lift. Engineers studying the wreckage calculated that the bomber's empty weight must have exceeded 70,000 pounds. The maximum takeoff weight, based on landing gear strength and wing loading calculations, likely approached 140,000 pounds. These figures represented an aircraft twice the size of Japan's largest operational bombers and 4 times the weight of the G4M that formed the backbone of Japanese naval bomber forces. But size and weight alone didn't determine combat effectiveness. What mattered was how that weight translated into operational capability. The Americans had apparently designed an aircraft that devoted a higher percentage of its gross weight to payload and fuel compared to Japanese designs that sacrificed bomb capacity to defensive armament, or sacrificed range to maintain speed, or made other compromises that limited overall effectiveness. Within weeks of Nakano's ramming attack, portions of the downed B-29 went on public display in Tokyo. The exhibition served propaganda purposes, demonstrating to Japanese civilians that American bombers could be defeated, that ramming attacks offered a viable defensive tactic, that Japanese pilots possessed the courage and skill to destroy enemy aircraft despite overwhelming technological disadvantages. Citizens filed past sections of twisted aluminum and steel, seeing physical evidence that the massive bombers filling their skies were not invincible. They viewed Nakano's damaged fighter, its crumpled nose and bent wings testimony to the violence of the collision. They read descriptions of the pilot's heroism, his willingness to sacrifice his aircraft and risk his life to protect Tokyo from American bombs. What the propaganda displays didn't mention was what Japanese engineers had learned from their examination of the wreckage. The displays didn't discuss the precision manufacturing that enabled such rapid production. They didn't explain the technological sophistication of the fire control systems or the pressurization equipment. They certainly didn't calculate the industrial implications of an enemy who could build such aircraft in quantities that would overwhelm Japanese defenses through sheer numbers. By December 1944, American factories were producing B-29s at rates approaching 100 aircraft per month from 3 separate production facilities. Boeing's plants in Renton, Washington, and Wichita, Kansas, were building the bombers alongside Bell Aircraft in Marietta, Georgia, and the Glenn L. Martin Company in Omaha, Nebraska. Total production would eventually reach 3,900 aircraft by the war's end. Japanese intelligence analysts, who understood American industrial capacity, knew these figures or close approximations through various intelligence sources. They could calculate production rates based on serial numbers observed on captured or downed aircraft. They could estimate manufacturing output based on the number of bombers appearing over Japanese cities. The mathematics proved devastating. Japan produced approximately 28,000 aircraft of all types in 1944, including fighters, bombers, reconnaissance aircraft, trainers, and transports. American production that same year exceeded 96,000 aircraft. The disparity in numbers alone told a story of overwhelming industrial advantage, but the numbers understated the real gap. American aircraft consisted of thousands of precisely manufactured interchangeable parts. They could be maintained by mechanics with basic training using standardized replacement components. They could be repaired in the field quickly and returned to service. Japanese aircraft remained craftsman-built machines requiring skilled technicians for maintenance, specialized parts for repairs, and constant adjustment to remain operational. Each American aircraft represented greater actual combat capability because it could be kept flying with less effort and fewer specialized resources. The B-29 embodied this American industrial philosophy completely. Everything about its design prioritized production efficiency, maintainability, and operational reliability over artisanal quality or aesthetic perfection. Panels were straight rather than compound curved wherever possible, simplifying forming operations. Fasteners were standardized throughout the aircraft, reducing inventory requirements. Systems were modular, allowing rapid replacement of failed components. Japanese engineers examining the wreckage recognized these design principles because they represented everything Japanese aircraft manufacturing was not. Where American designers optimized for mass production, Japanese designers optimized for individual aircraft performance. Where American factories used automated equipment and semi-skilled workers, Japanese factories relied on master craftsmen and hand-fitting. Where American logistics assumed abundant replacement parts, Japanese logistics assumed scarcity and required mechanics who could improvise repairs with limited resources. These fundamental differences in manufacturing philosophy had been developing for decades before the war began. American industry had embraced mass production techniques pioneered by Henry Ford and other automotive manufacturers. Japanese industry maintained traditions of craftsmanship that valued individual skill over systematic efficiency. Neither approach was inherently superior for all applications. Japanese craftsmanship produced aircraft of exceptional quality when built by skilled workers with adequate time and resources. American mass production methods produced aircraft of adequate quality in overwhelming quantities, with minimal skilled labor requirements. In peacetime, both approaches had merit. In a war of industrial attrition, only one approach could sustain the losses and replacement rates that aerial combat demanded. By late 1944, Japanese aircraft production was already declining under the combined pressures of American submarine interdiction, which cut off raw material imports, strategic bombing, which destroyed factories and supplier networks, and labor shortages, as experienced workers were conscripted for military service or killed in air raids. Monthly production of all Japanese aircraft types had peaked in mid-1944 and would decline steadily through the war's final months. American production, meanwhile, continued increasing. More factories came online. Training programs produced more workers. Suppliers expanded capacity. The arsenal of democracy that President Roosevelt had promised in 1940 was operating at full capacity by 1944 and would maintain that output through the war's conclusion. The B-29 represented the ultimate expression of this industrial capability. Not just an advanced bomber, but a systematic approach to aerial warfare that combined technological sophistication with mass production efficiency. The aircraft wasn't revolutionary because of any single advanced feature, though it possessed many. It was revolutionary because it demonstrated that America could build highly complex machines in quantities that would overwhelm any opponent who couldn't match such production rates. Japanese engineers understood this reality by examining the wreckage of Charles Fetter's bomber in December 1944. They recognized the precision manufacturing in every component. They acknowledged the systematic approach to systems integration. They calculated the production rates required to field the numbers of B-29s already appearing over Japan, and they reached the sobering conclusion that Japan could never match American industrial output using traditional manufacturing methods. The question facing Japanese military planners was not whether American B-29s represented superior technology. That much was obvious. The question was whether Japanese defenses could inflict sufficient losses to make the bombing campaign unsustainable before American bombs destroyed Japan's ability to continue fighting. The arithmetic suggested the answer was no. American B-29 operations from the Marianas began in November 1944 with raids against Tokyo's Musashino aircraft engine plant. The initial results proved disappointing. High-altitude precision bombing through Japan's notorious winter weather produced poor accuracy. Jet stream winds at 30,000 feet pushed bombers off course and scattered bomb patterns. Crews struggled with unfamiliar equipment and insufficient training. Losses to mechanical failure sometimes exceeded combat losses. But the Americans learned quickly. Training programs improved, maintenance procedures were refined, tactics evolved based on operational experience. By March 1945, when Major General Curtis LeMay implemented the revolutionary change to low-altitude nighttime incendiary attacks, the B-29 force had transformed from a struggling experimental command into the most devastating bombing force in history. The firebombing campaign that began on March 9, 1945, would ultimately destroy major portions of over 60 Japanese cities. The attacks killed hundreds of thousands of civilians, left millions homeless, and devastated Japanese industrial capacity. By August 1945, Japan's ability to continue the war had been effectively eliminated through strategic bombing. even before the atomic weapons demonstrated the ultimate potential of American technological dominance. The wreckage of Charles Fetter's B-29, destroyed by Matsumi Nakano's desperate ramming attack, had provided Japanese engineers with their first detailed examination of the aircraft that would bring such destruction. What they learned from that examination confirmed their worst fears about the impossibility of matching American industrial output using Japan's traditional manufacturing approaches. The bomber represented more than just advanced technology. It embodied an entire industrial philosophy fundamentally different from Japanese practice. It demonstrated systematic approaches to manufacturing that Japan had never implemented. It revealed the full extent of American industrial mobilization, and mobilization that would prove unstoppable once fully engaged. The examination of that December 1944 wreckage taught Japanese engineers everything they needed to know about why Japan would lose the air war over its home islands. Understanding the enemy's advantages, however, didn't eliminate them. Knowledge of American manufacturing capabilities couldn't create the industrial infrastructure needed to compete. Recognition of superior technology couldn't produce equivalent systems when the fundamental manufacturing base lacked the necessary precision equipment, trained workers, and raw materials. By late 1944, Japan's strategic position had become hopeless, though the fighting would continue for another 8 months. November 24, 1944. The island of Saipan. The air was thick with humidity and the smell of hot aviation fuel as hundreds of ground crewmen swarmed across the dusty runways of Isley Field. From horizon to horizon, the silver bodies of Boeing B-29 Superfortresses gleamed under the morning sun, massive machines unlike anything the Pacific had seen before. At the head of one runway stood General Haywood Hansell, commander of the XXI Bomber Command. He adjusted his cap, shielding his eyes from the glare as the first of his bombers began to roll. Engines roared in perfect synchronization, 4 Wright Cyclones per aircraft, each belching trails of black smoke as the propellers clawed at the humid air. The target that morning was Tokyo. For the first time in the war, the Japanese capital would be bombed directly by aircraft operating from bases under American control. A mission that represented the culmination of nearly 3 years of engineering, logistics, and strategic planning. Each aircraft carried up to 7,000 gallons of fuel and a 5-ton bomb load, pushing takeoff weights to nearly 140,000 pounds. Pilots had to coax their aircraft into the air at the very limits of physics. One slight miscalculation, one loss of engine power, and the overloaded bomber would stall and crash into the sea. From the start, the mission revealed both the promise and the peril of the new aircraft. The B-29 seconds climbed slowly to altitude, circling the Marianas to form up in massive combat boxes before setting course northwest toward Japan. It would be a 3,000-mile round trip, more than 14 hours of flying over open ocean. Inside the lead bomber, Lieutenant Colonel Robert K. Morgan, veteran of the Memphis Belle, watched his instruments carefully. The cabin temperature was warm and pressurized, but the strain showed on every face. The B-29 was still experimental in many ways. Engines overheated, turbo-superchargers failed, and oil leaks plagued early flights. Mechanics on the islands worked around the clock to keep the aircraft flying, often cannibalizing parts from wrecked planes to maintain operational strength. By early afternoon, the bombers reached Honshu. Japanese radar detected them long before they arrived, and air raid sirens wailed across Tokyo. Civil defense workers rushed to shelters. Anti-aircraft crews scrambled to their guns. But few among them truly understood what was coming. The B-29 seconds approached at 30,000 feet, flying higher than any previous enemy aircraft had reached. Japanese Type 88 anti-aircraft guns, designed in the 1,920 seconds, barely reached that altitude. The shells exploded far below, the bomber formations, harmless puffs of black smoke in the blue sky. At 12:15 p.m., the first bombs fell on the Musashino aircraft engine plant, a vital center of Japanese aviation production. From above, the bombardiers watched the target through their Norden sights, adjusting for wind drift and jet stream interference. The bomb bay doors opened, and tons of high explosives tumbled earthward. For the Japanese below, the sound came first, a deep, distant rumble that grew into a rolling thunder. Then, the explosions ripped through the industrial district. Fire and smoke erupted from the Musashino complex. Within minutes, secondary explosions tore through the plant's fuel storage tanks. But accuracy was poor. Out of 111 bombers dispatched, fewer than 20 hit the intended target area. High-altitude winds, the now infamous jet stream, still poorly understood scattered bomb patterns over dozens of miles. Entire formations drifted off course. Some bombs fell harmlessly in open countryside, others in residential areas miles from the target. The results were disappointing. Damage assessments showed that the factory remained largely intact, and the Japanese quickly repaired what destruction had occurred. Yet even as the smoke cleared, the psychological effect of the raid was profound. For the first time, ordinary Tokyo citizens had witnessed the reach of America's new bomber. Their city, the heart of the empire, once believed untouchable, had been struck. Among the defenders, pilots like Corporal Matsumi Nakano, who would later ram Lieutenant Fetter's bomber, took note of the high-altitude contrails arching across the sky. Their own Ki-44 Shoki and Ki-61 Hien fighters struggled to climb high enough to intercept. Even when they reached the bombers, their guns froze in the thin air, and their engines gasped for power. The Japanese high command was shocked. They had expected the Americans to use China-based airfields for sporadic raids. They had not foreseen the speed with which the Marianas would become fully operational. Intelligence officers calculated that at least 150 bombers had taken part in the first Tokyo strike. What they could not yet know was that thousands more would follow in the coming months. In the aftermath of that first mission, General Hansel reviewed reconnaissance photos and realized how little damage had been achieved. His reports were optimistic in tone, but private notes told a different story. The B-29 seconds had performed mechanically, but the strategy had not. Weather, wind, and inexperience had neutralized their technological advantage. Still, Hansel believed in the precision bombing doctrine. He insisted that further raids, carefully planned and executed under better conditions, would cripple Japan's war industry. His superiors, however, were losing patience. The Joint Chiefs of Staff wanted results, not experiments. By December, even as Matsumi Nakano's ramming attack shocked the Japanese, the Americans were questioning whether the B-29 could deliver on its promise. Engine fires, mechanical failures, and navigation errors continued to take a heavy toll. Dozens of bombers were lost without ever reaching their targets. Yet, every week, more aircraft arrived from the mainland. Crews were trained, tactics refined, and the massive logistical machine behind the Superfortress campaign continued to expand. The growing presence of B-29 seconds over Japan was only the beginning, and both sides knew it. For Japan, the December 3rd collision offered a fleeting symbol of resistance, one pilot's self-sacrifice bringing down a mighty enemy. For the United States, it was a reminder that technology alone could not guarantee victory. The campaign against Japan would need not only machines, but men willing to rethink how air warfare itself was waged. Because by early 1945, new leadership was coming, and with it, a new, far more devastating strategy. February 1945, the Marianas, rows of superfortresses shimmered in the tropical heat, their silver skins already dull from salt and sun. In the command tent at Guam, Major General Curtis Emerson LeMay studied the mission reports that covered his desk columns of numbers, coordinates, and losses. The facts were undeniable. After 3 months of high-altitude daylight raids, Japan's war production remained largely intact. Precision bombing, the doctrine he'd once championed in Europe, was failing over Japan. The problem wasn't the aircraft. The B-29 Superfortress could fly higher, farther, and carry heavier loads than any bomber before it. But the realities of Japan's weather, the jet stream's 200 mile-per-hour winds, the perpetual cloud cover, and the primitive navigation aids made precision impossible. Bombs scattered over miles, and photographic reconnaissance often showed entire target areas untouched. LeMay had inherited command from General Haywood Hansell, who'd been relieved for failing to deliver decisive results. LeMay understood what that meant. He would not be given long to prove the bomber offensive could work. In late February, he summoned his group commanders. The young general, only 38 years old, spoke quietly but with the authority of experience. "If we can't hit their factories," he said, "then we'll burn their cities." The logic was brutal. Japanese industry wasn't concentrated in vast complexes like those in Germany. It was scattered among homes and workshops, woven into the fabric of urban life. Thousands of family-operated machine shops produced aircraft components, weapons parts, and munitions casings from within densely packed neighborhoods. Destroying those cities meant destroying the nation's industrial base and, inevitably, its civilian population. LeMay's plan was simple in concept and radical in execution. Instead of flying at 30,000 feet through freezing winds, the B-29 seconds would fly at night, at altitudes below 7,000 feet. And they would carry incendiaries, not high explosives. He ordered crews to strip out most of their defensive guns and ammunition to make room for extra bomb load, a decision that horrified some pilots. Without guns, the bombers would rely on darkness and speed for survival. On the evening of March 9th, 1,945, more than 330 B-29 seconds lifted off from Guam, Saipan, and Tinian. The target, Tokyo. Each bomber carried up to 7 tons of incendiaries, napalm-filled M69 bomblets, and clusters of magnesium and white phosphorus, designed to ignite instantly upon impact. At 12:08 a.m., the lead aircraft, the LeMay's Lady, reached the city and released its first load over the Shitamachi district, a dense residential area of wooden homes and narrow alleys. Within minutes, the heart of Tokyo was aflame. From the air, crewmen watched in stunned silence as a sea of fire spread beneath them. The fires merged into vast whirlwinds of flame, feeding on the oxygen drawn upward by their own heat. The firestorm created winds exceeding 100 miles per hour, sucking people, debris, and entire houses into the inferno. Below, civilians fled through streets that had become rivers of fire. The heat was so intense that it melted the aluminum of cooking pots and the glass of windows. Canals and rivers boiled with floating corpses. The temperature in the core of the firestorm reached 1,800 degrees Fahrenheit. When the last bomber turned for home hours later, 16 square miles of Tokyo lay in ashes. Over 100,000 people were dead, most burned or suffocated in the smoke. It was the single deadliest air raid in human history, surpassing Dresden, Hamburg, or even Hiroshima. LeMay, upon receiving the first reconnaissance photos, said little. The images spoke for themselves. Entire districts were erased. Rail lines melted into the earth. The few factories that survived stood amid seas of charred ruin. The bombing accuracy had finally improved, not because the aim was better, but because at low altitude there was no need for precision. The target had been the city itself. In Washington, the Joint Chiefs called it a triumph of strategy. In Tokyo, it was a revelation of despair. Emperor Hirohito's advisors could no longer deny the vulnerability of the home islands. If one city could be burned to the ground in a single night, all could. Over the next 3 months, LeMay's bombers repeated the attack across Nagoya, Osaka, Kobe, Yokohama, and dozens of smaller cities. The campaign destroyed over half of Japan's urban area. By June, more than 9 million people were homeless. Among the Japanese engineers who had once examined the wreckage of Lieutenant Fetter's B-29, the irony was unbearable. The machine they had studied in December, that marvel of industrial precision, had now become the instrument of their nation's immolation. They had understood its power in theory, now they witnessed it in fire. By midsummer, Japan's aircraft factories were silent, its fuel reserves exhausted, and its cities in ruins. Yet the B-29 seconds kept coming, flying almost unopposed. The last remnants of the Imperial Japanese Air Force could barely scramble interceptors. Pilots like Matsumi Nakano, who had once rammed a bomber with his own aircraft, were now remembered as symbols of courage in a war that no longer offered victory, only endurance. Then, on August 6th, a single B-29 named Enola Gay appeared over Hiroshima. 3 days later, another, Bockscar, over Nagasaki. Each carried a weapon far beyond even LeMay's comprehension weapons that would make the firebombings seem almost conventional by comparison. When Japan finally surrendered on August 15th, 1945, the skies were quiet. The war that had begun with sword and carrier had ended with aluminum, fire, and the inexhaustible machinery of industry. And somewhere in a field outside Tokyo, where the wreckage of Lieutenant Fetter's Superfortress had once been studied piece by piece, the last fragments of metal still gleamed in the sunlight, silent reminders of the moment Japan first glimpsed the force that would one day bring its empire to ashes. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell, so you don't miss any upload from us.